Hello everyone, I'd like to introduce myself before I give the talk. I'm Professor Fernando Andreote. I work at the University of Sao Paulo, NAICC, in Piracicaba. What my group has been doing over the last few years has led us to seek a better application of microbial concepts in agriculture, a worldwide trend with various specialties in Brazil, which I hope to show you a little bit today throughout my talk. Well, I'd like to start at the very beginning, where I'm going to look at the general equation that permeates the agricultural process, where we actually find this concept of microorganisms working for us. So, I'm going to look at this equation which says that the phenotype is the result of the interaction between the genetics of the plant and the environment, where this equation includes the microbiological part of the soil associated with the plant. So, we have to understand first of all that the interaction of these two factors is what gives us productivity, product quality. This is success in agriculture, and this environmental factor is very strong for all of us, because it modulates the genetic potential of the plant. This genetic potential, developed by breeding programs, by transgenics and other processes, but the environment has a strong factor here for the success of agriculture. And this environment can even be shared between the atmospheric component and the soil component. So the soil becomes a key element of success. Why? Because it is a large part of the environment, and because it also has the potential to mitigate atmospheric stress, something that is very much related to current climatic conditions, with the expansion of agriculture into marginal areas. So soil is a key element, and within this soil element fraction we will find the different components of soil quality. Natural soil quality, pedology, geochemistry, physical quality, partly determined by texture, partly determined by the formation process, partly determined by our management. The most exploited chemical quality of all in agriculture, where we talk about nutrition, fertilization, and biological quality. So we found our main component, as I said, which is this biological component that is part of the larger concept of soil quality or health, which aims to promote the best possible plant development, to promote a differentiated plant, a production with better quality, greater quantity, and also has the mission of this soil quality to guarantee two quality end products in the agronomic process. What are the two products? Productivity, what we harvest and sell, and the soil that remains for the next crop cycle. So we realize that this concept of quality, of soil health, is very much involved, very directly linked to the success of agriculture. And this biological component is part of this process, part of soil quality. So, let's observe that this biological component, which is part of the soil's biological process, part of the soil's formation, part of the activities we carry out in agriculture, acts as a great biological sensor that responds to the management we carry out on the soil. All this miscellany, this biodiversity of organisms, macro and microorganisms that interact in the soil. Down here we have some numbers of the dimension of this life that we have in the soil. This whole process is the result of the process of soil formation itself, but it is also shaped in its composition and activity by the management processes that we apply to the soil. So, we can think that in some way we have the capacity to alter the composition and biological activity of this soil. Well, why is this important? Let's assign these biological components the functions they can have. So, today we understand that this biological part of the soil, and I'm referring more to microbiology, which is where I work the most, is directly related to the physical part of the soil, to the structuring of the soil, to the porosity of my soil, to the ability of this soil to form aggregates. So it was in pedology, so it is in land use. It has a direct relationship with nutrient cycling, with the transformation of chemical elements that sometimes take on soluble forms. The whole process of making nutrients available in the soil is mostly done by biological activity. It is related to plant protection, by simple processes of defense protection, suppression of diseases, And it is also related to carbon storage, carbon stabilization, both because it cycles organic matter, as well as generating more stable forms of carbon in our system. So all of this gives us a great insight into the fact that this biological part carries out fundamental processes in the soil, processes that bring the soil a better quality that we offer to the plant. Within this concept, our challenge is to promote this biological composition, or this biological sizing, in the best possible way within agriculture. But this becomes, as well as an opportunity, a great challenge. Why a challenge? Because in an agronomic system, in an agricultural system, we have a series of transformations that change the environmental condition of my soil. So, if we consider the condition we have in cultivated soil for the establishment of biological functions, we realize that all these items that are here are items that we humans have transformed in the soil in order to carry out agriculture. We homogenize the cultivation of plants, we use pesticides, we rotate the soil, we prepare the soil. All of this changes the environmental conditions and often causes the soil to decrease its quantity and its life activity, its biological activity. So this depletion, this loss of biodiversity, this decrease in biological activity, is commonly found in cultivated soils. This is because cultivated soil is much simpler. From an environmental point of view, it is more selective. In other words, it allows less biodiversity to be installed and it ends up losing part of the biological processes that occur there. When we start to learn about this, and the literature is quite vast on this subject, we then realize that there is an opportunity for us to incorporate biological management into the agricultural system. In other words, in addition to thinking about plant fertilization, in addition to thinking about soil preparation, in addition to thinking about plant stimulation, we can work on building the best biological soil system. And how does this happen? It happens in combination with all the factors you have here. Why? It's not simply a matter of removing these processes, because that would lead to a loss of agronomic efficiency. These processes are mandatory for anyone who is successful in agriculture most of the time. So we have to be efficient in combining and coupling the biological part of these processes. This is still an initial process, under construction, with many things developing. But we can already organize this process a little. Look what we can think of. I hope to share this knowledge with you in the next few slides. But I would like to say that the main headlines, the main guidelines for managing soil biodiversity in agriculture, go through two major blocks of actions. One very intuitive and the other not so much. The most intuitive is the first one, where we say that the inoculation of beneficial organisms is important. Yes, there is a growing worldwide trend, perhaps even stronger in Brazil, to apply microorganisms to the soil during cultivation on plants, and for these microorganisms to perform functions. Since we're going to see how we're doing with this in Brazil, it can be used for plant protection, plant nutrition, stimulating rooting, etc. However, the other important and complementary line is to promote better environmental quality in the soil, in other words, to recover parts of the environment that we have lost in the soil. If I've just shown you that we've lost biodiversity, how can we recover that biodiversity? And here we're going to have to think about soil as an environment. Let's look at this together in two slides. First of all, let's return to the item above and understand what this application of beneficial microorganisms to plants means in Brazil and around the world. In the Brazilian scenario, this aspect talks about a growing market for bioinputs, which works on this scale. These are figures for the Brazilian bioinput market. The application of biological products in Brazilian agriculture. This market didn't even reach 3% of cultivated areas a few years ago, 7 or 8 years ago, and today it reaches more than a third of the areas. So it's a fast-growing market. showing its potential to bring gains to agriculture in Brazil, and showing that it's a market that brings something we weren't seeing. This has everything to do with the theory of microbiology, forms of microbiology, etc. But it's a growing market and one that today reaches most of Brazil's rural producers. But we're at an international meeting and the idea is also to show the world. And in order to show the world, we needed figures until a survey, which I've even provided the link to so you can access it here, showed a series of factors for agriculture at the beginning of 2023. And I was very interested in this survey because it shows exactly what the different panels will look like, and I'm going to use some more of them later. This panel, which talks about the adoption of biological components, is divided into biocontrol agents for plant protection, biostimulants, which are for plant growth, and biofertilizers, which are nutritional for nitrogen fixation, phosphorus and potassium solutions, etc. And we see how the people who took part in this interview respond to these concepts. We see a clear leadership from Brazil in the adoption of biological products. This color here means I'm already a user of the technology, and down here we have the world average. The world average for the use of these technologies was very much driven by Brazil. Today, Brazil is the main point of use, development, mistakes and successes regarding biological products in agriculture. So this growing market that I've shown you, from 3% to 36% of cultivated areas, is fostered by results. It's fostered by the dissemination of information by concept. So much so that we saw another interesting thing here. The answer, I've never heard of it. It's always zero in the interviewees from Brazil, because this information permeates the agronomic scenario in Brazil. So we dare say that Brazil is leading this process, with mistakes and successes, but trying to show the real potential of microbiology to add value to world agriculture. Very well, this is the scenario we have for the application of beneficial microorganisms, which is one of the fronts. When we move on to the other front, and also an important action front, where we talk about promoting better environmental conditions in soils, remember that these fronts are complementary. If they work together, then we have a bigger mental workload. Then we have to think of the soil as an environment, knowing that there are different forms of life there and what management practices are helping or hindering the construction of greater biodiversity. So I can tell you briefly that our time is short and that soil preparation is always a problem. On the other hand, plant diversification, which is at the other end here, is always beneficial. It always brings diversity of organic matter, diversity of carbon, diversity of root exudation. It always promotes biodiversity. And the inputs that are much discussed in this scenario, they have highly variable effects, both fertilizers and pesticides. I need to think about which molecule it is, the amount applied, the recurrence of application and also the soil that is receiving it. The same molecule, in the same dosage in two soils, has different effects on biodiversity, because that biodiversity is capable of mitigating the stresses that I can induce in that soil, more or less efficiently, according to its biological capacity. So this input factor will remain for a long time, requiring information about its interaction with biodiversity. But when we do a project along these lines, we try to find out exactly what each of the biological factors is, and how it interferes with the biodiversity process in my soil. The idea is to create a more functional system for the biological part. Well, using the same study that we saw back there, there's a screen that I really liked, a survey that I really liked, which I brought for us to look at together, which talks about conservation practices, which is somehow connected with this, with thinking of the soil as an environment. So we see that underneath there is low tillage, cover crops, controlled fertilization, and variable rates. And here again we see that the world average is now higher, because technology in agriculture used to be more widespread as a whole, which is the biological part, but we still have Brazil in a strategic position, in some cases very close to the United States and Europe, but this means that this part can be done. Because when I plant a cover crop, I'm helping the soil's biodiversity. When I work with low tillage, I'm helping the accumulation of carbon, the saturation of my soil. Regardless of this, I'm taking my soil to a better environmental condition. So, we realize that this front of creating better soil is also functional, also possible, also active on the Brazilian scene, on the world scene. So, realize that the crop is prepared to incorporate the microbiological part into its production system. We have a very strong industrial front at the moment for the application of microorganisms, and we have a scenario that calls for soil conservation. This together gives us the chance to look at the biological part as an integrated and active factor in the management process. So now I've just gone back to my screen so we can see what we can see from each of the factors. So, within the headlines for managing soil biodiversity, the inoculation of beneficial organisms is important, it's technological, it's growing. We are copying nature, applying microorganisms in a more intense and localized way. In Brazil, this is called bio-inputs, and Brazil now leads the world in this area. As for improving environmental conditions, this has a lot to do with soil quality. It's about preserving moisture, soil cover, organic matter, looking at salinity, toxicity. We're trying to find plant diversity, greater plant biomass, in other words, transforming the soil into a rich and receptive environment for life forms. Also because when we do this part down here well, we enhance the activity of the beneficial organisms that we inoculate into the soil. So you can see that this is a very interesting scenario of how we structure the forms of management and generate actions based on this. Well, let's move on to the final part. I wanted to talk briefly about how we have evidence that this biological part is improving, that I have biological activity, that I have greater biodiversity. So logically there's biological analysis of the soil. I'm going to talk about it briefly for you, but first I have a pyramid here, a gradient of success that we call, starting here from the bottom, we build up these stages until we reach the top. We have an improvement in nutrient cycling. Whenever we improve the biological part of the premise, we have better root protection, lower disease rates, better soil structuring, better pesticide degradation, less phytotoxicity, and the plant responds to all this with better rooting. And obviously, with a plant rooting better and a soil with all these characteristics, it suffers less and ends up giving us better productivity. You see, there's a whole connectivity between these factors, which often, on field days, on practical visits, we end up finding these indicators and it's not always connected to the biological part of the soil. So this often saves our field days. But to prove it with the fear of involving technology, we need more. So, when possible, when available, we always use biological soil analysis to show this success in biological soil improvement. So, I won't have time to go into biological analysis here, but it's a worldwide trend to look for biological analysis for soils, to generate parameters, numbers and interpretations, from cultivation methods to molecular methods. I would say the most refined of all. And along the way there are indicators. Indicators mean that, regardless of what I want to measure, or depending on what I want to measure, I can look for specific or general factors or analyses that give me some laboratory guideline to say, this biological situation is better than it was before. This is quite broad, quite dense with information, but basically it's laboratory analysis that gives me figures that show improvements in the biological part. What does the world look at today in this relationship? Here's what the world is looking for today when it comes to agricultural applications. Something that meets three demands: reduced analysis time, analytical speed, ease of interpreting the results and cost efficiency. Obviously, it's not easy to combine all this, but the idea is that we can work on all these factors to meet the demands of the producer who wants to send in his sample, get the result quickly, be able to interpret it, and then make decisions in his agricultural production process. This is a gradient of what we see happening there in Brazil. We have some very beautiful work being done with enzymes, with soil biological activity, but DNA sequencing is leading the way on a global scale, which is what we are most looking for in order to better understand the biological composition of soils. Well, that's the concept I wanted to bring to you. This last slide just shows a little bit of what our laboratory does here in Brazil. We have a series of projects. I'm not going to read them all because of the time, but obviously you can look at them quickly. But our objective, our research group, is to put concepts of microbial ecology into agriculture, always leading to greater efficiency, always marrying productivity and sustainability, because we believe in this biological capacity to aggregate the process. So, to finish, I'll leave you my 2 emails. All contact will be very rewarding. Please write, ask questions, and I'll end with a key showing that microbiology is a key component in soil quality and that soil quality is fundamental to supporting agriculture properly. Thank you all very much. I wish you a great event, success, and until next time.